Hello, I am going to demonstrate one of the demos flow for Node.js. This demo showcases two exclusive features for Node.js, which are the process snapshots and the event loop monitoring. By leveraging this functionality, our customers can correct common performance issues in a much more elegant and efficient way. In this particular demo story, the transaction affected by poor performance is directly tied to the revenue. The name of this transaction is buy, and correcting issues with this transaction translates into immediate dollar value. I'm using the Movies Ticket online application. The context of this demo is as follows. In the last few hours, ticket sales via mobile have decreased. This is very strange because there is no change in the mobile traffic and the app seems to be working just fine. Also, ticket sales via the web application seems pretty normal. The web and mobile infrastructure use the main.NET application. However, some of the mobile requests, including the buy transaction, are served by the Node.js tier. The technical team is brought in to fix the problem ASAP, and they turn into app dynamics, and quickly they can verify. At a glance, they can see the traffic, and they can verify the general application vitals. Next, they move to the business transactions, and immediately notice a performance issue with the buy transaction. Now they know what the problem is, and they need to understand now what's causing it. And the first step is to look the complete set of instructions executed by the CPU while the buy transaction was in flight. The process snapshots in App Dynamics provide these insights. Let's go there. Let's check out the call graph. Okay, and yes, right over here, we can see the instruction taking 93.4% of the CPU time, taking at least 8 seconds to execute, and we know the exact module, function, and line of code blocking the CPU, forcing requests to wait, and of course causing performance issue. Let's verify our theory by looking one more data point, the event loop. And this confirms what we suspected. We can see the 10 seconds over here. A long running instruction is blocking the CPU for 10 seconds and impacting the buy transaction performance. And to add a little bit more color to this story, if we were going to look into the application code, we would see that the fab actors function, which if you recall is on the instruction blocking the CPU for about 8 seconds, is not invoked by the buy transaction, but instead by the user preference transaction. This situation clearly highlights the need for entire visibility into the CPU workload when buy was in flight. Without App Dynamics, discovering the root cause of this problem could have required a lot of time, application knowledge, and effort, increasing the probabilities of negatively impacting a revenue opportunity. In contrast, by leveraging iDynamics process snapshots and event loop monitoring, within a few minutes and with a few clicks, we uncovered not only what the problem was, but what was the cause of it at the function and line of code granularity level.